So hello everyone, welcome back to the channel. In previous lecture, we will discuss the basic introduction of thermodynamics and its importance in our daily life by simple example. Then we see system and its surroundings and boundary and their types with simple example. So today we will study some more important topics of thermodynamics. In this lecture, we will understand its a states of the system and function of the system like state function and path function and properties of the system like intensive properties and extensive properties. Then we see types of thermodynamic process like isothermal process, adiabatic process, isochoric process and isobaric process. So stay focused till the end of this video because this lecture is very important for your board exam and competition exam. So let's move to the screen. So this is third part of this chapter, that is states and function of the system and thermodynamic processes. So what is state of system? Condition of a system that described by measurable properties like temperature, pressure or volume, composition of system. For example, consider a gas kept inside a closed container. If temperature of gas is 300 Kelvin and pressure is 2 atm and volume is 5 liter, then these three values, pressure, volume and temperature, describe the system of a gas. If any one of these values changes, for example, temperature increase 300 to 400 Kelvin, then system move to new states. So next is types of function. There are two types of function. First, state function and second is path function. So let's firstly define what is state function. A state function is a property of a system that depends only on the current state of the system, not on how the system reached that state. Changes in state function depend only on the initial and final state, not on the path or process taken between them. For example, the height of mountain depends only on where are you standing, not on which road you use to reach there. For, for example, you can choose this zigzag line or you can choose this straight line for reaching at top of mountain. The height of mountain never be changed by changing the route to reach top of mountain. So the height of mountain is a state function because it never changed by changing the route to reach it top of mountain. So let's understand a state function by other example. So let's consider two cases. First case, temperature change in single step, and second case, temperature change is multiple step. So let's suppose initial temperature is 300 Kelvin and final temperature is 350 Kelvin. So let's consider first case. In first case, temperature changes from 300 Kelvin to 350 Kelvin in single step. So the total temperature change is 50 Kelvin. And second case, in this case, temperature changes from 300 Kelvin to 350 Kelvin in multiple steps. In first step, temperature changes from 300 Kelvin to 320 Kelvin. And in second step, temperature changes from 320 Kelvin to 340 Kelvin. And in final step, temperature changes from 340 Kelvin to 350 Kelvin. So in first step, temperature change is 20 Kelvin. And in second step, temperature change is also 20 Kelvin. And in final step, temperature change is 10 Kelvin. If we add temperature changes in these three steps, the total becomes 50 Kelvin. So we can see that in both the cases, temperature change is same, that is 50 Kelvin. So now we can conclude that the temperature change only depends on initial and final state. The other example of state function is internal energy, enthalpy, volume and pressure. So next is second type of function, that is path function. A path function is a property that depends on the specific path taken to reach a particular state. Its value never changes depending on how the process occurs. For example, the distance you walk to reach a top of mountain depends on which path you choose. If you take a straight path, the distance is less, and if you choose the zigzag path, the distance is more. So the distance depends on the path. That's where it is a path function. In previous example, we said that the height of top of mountain is a state function, while in this example, we are saying that the distance of top of mountain is a path function. So never get confused between them. So let's understand work is an example of a path function by plotting graph between pressure and volume. So let's consider first case. In first case, system goes from state first to state second by path A, and the area under the curve is a work done by the system through this path. So now we can denote that the work done by the system through this path A is a WA. So in next case, system goes from state first to state second through part B, and the shaded area show work done by the system through this path. In this case, we can denote work done by the system through part B is W2. It is different because work done through path B is different from work done through path A. Since areas are different, because of that, work done are also different through this path A and B. But both the part start at same point, that is point 1, and end at same point, that is point 2. So now we can conclude that even if initial and final stages are same, the work done depends on path taken. Therefore, work done is example of path function. Other example of path function is heat. So next is the difference between state function and path function. So let's quickly see the difference between them. First, state function depend only on initial and final state of the system, while path function depend on the path taken between them. State function is independent of the process followed, while in path function different process give different values. Third, in state function, changes in any variable is written as delta x is equal to x2 minus x1. For example, change in internal energy is written as delta U is equal to U2 minus U1. While in path function, change in any variable is written using inexact differential. For example, change in heat and work is written as del Q and del W. Fourth is, for state function, cyclic integral is 0, while for path function, cyclic integral is non-zero. Fifth, for state function, value is fixed for given state, while for path function, value changes with states. Sixth, state function represent property of the system, while path function represent energy transfer during the process. The examples of state functions are internal energy, enthalpy, entropy, pressure, volume, and temperature, and etc. The examples of path functions are heat and work. So next topic is types of thermodynamic processes. There are several types of thermodynamic process like isothermal process, isochoric process, isobaric process, cyclic process, and adiabatic process. So let's start with isothermal process. So what is isothermal process? A process in which temperature of the system remains constant throughout the process is called an isothermal process. Heat is exchanged with surroundings to maintain constant temperature of the system. For ideal gases, PV is equals to constant during isothermal process. The melting of ice cube at 0 degrees Celsius is an example of isothermal process. So next is isochoric process. A process in which volume remains constant is called an isochoric process. No work is done in this process because volume does not change. For example, heating gas in sealed rigid container. Next is isobaric process. A process in which pressure remains constant is called an isobaric process. In isobaric process, volume remains constant because to maintain equilibrium of system. For example, heating water in open vessel at atmospheric pressure, example of a isobaric process. Next is cyclic process, a process in which a system returns to its initial state after a series of steps is called an cyclic process. Cy- In cyclic process, initial state is equal to final state. During cyclic process, internal change is zero. The example of cyclic process is Carnot engine. Work done by the Carnot engine is determined by plotting a graph between pressure and volume. In this graph, process start at point 1 and then goes to point 2 and 3 and finally return to its initial point, that is 1. So next is adiabatic process. A process in which no heat exchange between system and surrounding is called an adiabatic process. Temperature changes during the process to maintain equilibrium of the system. Adiabatic process occurs in isolated system. For example, expansion of a gas in thermos flask is ideal case of adiabatic process. So next topic is types of property of the system. There are two types of properties. First, intensive, and second is extensive. So let's firstly define intensive property. The property whose value does not depend on the amount or size of the system are called intensive property. They remain same whether the system is small or large. These values are independent of the mass. For example, if you divide glass of water into two parts, the temperature and density of the each part remain same, hence they are intensive property. The other example of intensive properties are temperature, pressure, density, concentration, refractive index, specific heat capacity, molarity, etc. Second is extensive properties. The property whose value depends on amount or size of the system are called extensive properties. They change when the amount of matter changes. They are additive in nature. For example, if you combine two identical containers of water, the total volume of water and mass become double. Hence, they are extensive properties. The other example of extensive properties are mass, volume, internal energy, enthalpy, entropy, number of the moles, and etc. So next is the ratio rule. What is ratio rule? The ratio of the two extensive property is always intensive properties. For example, density is equal to mass upon volume, where density is intensive property and mass and volume are extensive properties. The other example of ratio rule is specific heat capacity and molarity. Specific heat capacity is equal to heat capacity upon mass, where specific heat capacity is intensive property and heat capacity and mass are extensive property. And third example, molarity. Molarity is equal to moles of solute upon volume of solution, where molarity is intensive property and moles of solute and volume are extensive property. So next is, let's solve this question. 1 liter of water has density of 1 gram per ml. If the half liter of water is taken out from it, what will be the new density of water become? So the solution is half liter of water will be have same density, that is 1 gram per ml, because density is an intensive property, so it cannot be added or subtracted. An intensive property does not depend on amount of substance, or therefore both 1 liter and half liter will be have same density. This is your homework question. Please solve it and comment answer of this question in comment box. So if you found this lecture helpful for you, please like the video and share with your friends, and subscribe to the channel for more clear and comprehensive chemistry lectures. So see you in next lecture. Keep learning, keep growing.